All right, 2 minutes to go. Don't I look handsome? You know, Dalton Connor, if you do it correctly, you can actually determine the latency, accurately determine the latency of Zoom.
By doing that infinite mirror thing.
Exactly.
I think I might have seen a video on that on YouTube, but it was a while ago.
People on YouTube are very smart, aren't they?
They are.
Okay. Let's see. Goddamn Zoom. Okay, is it time? No, it's not. Okay, it is time. Dalton is here, and Eric. I don't see Eric, but I'm sure he'll arrive at some point. Yeah, I don't see Eric. Okay, Caleb. Not seeing Caleb. All right. Brandon is here. Kevin is here. Michael. That's right, Blake. You can now code on the world's fastest supercomputer in assembly language, taking advantage of multiple cores. So very cool. Okay. So where was I? Brandon is here. Kevin is here. Michael is not here. Michael. Okay. Connor is here. RJ will be here as soon as I close out the window. Davison is here. Chris is here. Sydney is here. Right, Sydney? Yep. Blake R is here. Joe's here. Blake S is here. Let's see. Blake R. Let me just make sure. Blake R. I know Blake S.
I'm here.
Thank you. Dan is here. James, I think I saw James. James. Yep. Hi, James. Amanda is here. I think so. Yep. And Alejandro is here, and Nicholas is here. Yes, Nicholas. Yep. Hi, Nicholas.
Here.
And Noah is here. Okay, so I have pushed save, which means it's now safe for everyone else who's missing to arrive. Eric. Caleb. And RJ. All right, let's move on. How do you get rid of the chat? There, go away. Okay, I am going to show you a project which has been assigned, though it is not yet complete. But it is complete enough for you to get a flavor of the project. It will be due, I believe, 2 weeks from Friday. Okay. And Friday, by the way, reminder, there's no class. There is a break. Friday and Monday, there'll be no class. I know that you are going to miss me as much as I'm going to miss you. So
Are you still going to be available to contact through like email or Discord?
No. Where I live, it's a very pious community, and they actually disable electricity during that
Okay, can I get an
holiday.
actual answer, please?
Okay. What do you think?
I'm going to assume yes.
Okay, good. That's a good assumption. All right. I'm available. Hey, I was a half a world away, and I was still answering email. Okay,
That's
so
fair. I didn't know if you had like a break-long supper or something.
yeah. Okay, so you can see this beginning of the specification. The idea is a multi-programmed tanks implementation, where tanks is the classic 8-bit, in this case, 1-bit retro game where there is some terrain, which I'll demonstrate for you, 2 players, and you trade off launching shells at each other. I've done this in a CS2, so it's an enjoyable experience to some degree. I mean, it is a game, but the wrinkle is I've made it so that it's going to go through the lessons of pipes and fork and exec and multi-programming. So notice I said multi-programming, not multi-threading. There's not going to be any threading in this. Instead, your program is going to launch my program. My program is going to be responsible for doing the calculating. Your program is going to be responsible for launching my program, presenting the user interface, and collecting input from the user. Sending that input to me, I send you back rendering instructions via a series of pipes. You will get the controller program in source code form, and having that source code is not going to help you do this project, not at all. However, that's not completely true, because you'll see if you're confused about how a particular message works, you can see the source code that is generating the message. I'm providing the source code rather than an executable, which was my first choice, because some of you might be developing on the Mac, some on Whizzle, some on ARM-based Linux, and that would mean I'd have to keep current 3 executables. So instead, you worry about the executable for the controller. This is what you need in order to build it. Okay, so get Come on. Thank you. All right, so your program is going to be standalone in that you will launch it, and it will be the parent of a parent-child relationship. My program is going to be the child. You will have to figure out how to successfully do that by creating a pipe and manipulating the file descriptors, and then causing the exec to take the fork and exec to take place. This is how you will launch my program from inside your program. Notice the executable for my program needs to be the // means the executable is wherever your executable is. Then you'll specify command line arguments. First is number of columns. Next is the number of lines. Since you're using curses, you only get access to the number of lines and columns after curses is already initialized with init scr. So I'm reminding you of that. This section discusses other hints about let's see, I got to fix that double asterisk there, about other configuration. Now, here's what's going to happen. You're going to have two pipes. One, well, pipes are unidirectional. There's a read side and a write side. We're going to go over pipes today. So your program, the data flow through one pipe is all the data going from you to me. And then the other pipe is all the data going from me to you. Okay, so examples of what you have to send me include the input that you collect from the user when you're told to collect input from the user. That input will be in the form of player one fired a round at such and such an angle with such and such a power behind it. Player one moved to the left, player one moved to the right, that sort of thing. Okay, so messages that come from me to you is you may get a usage, in which case you didn't launch me correctly. You may get resolution, which says that you need to make a terminal screen with more characters. The minimum is 120 columns by 48 lines. So you can do that by zooming out in your terminal and then making it full screen, and you'll have lots and lots of characters. All right, and there's an admonition that you need to call endwin properly to exit the program. So things that I'm going to send you are at such and such a line, at such and such a column, you should draw a certain character. The controller is going to create a game board, which is lines -2 by cols -2. This means you get to draw a border around the image. Notice that placing the players is this exact same. You don't really care where the players are. Remember, you're not doing any of the calculating. My program is. So I just tell you where to draw them. Another command that you might get is p-value. We'll discuss that when we get to it. Another one is refresh. When you're told to refresh, you should draw a box. You should draw the player one info, player two info, and then call the end curses refresh. Getting input from the user. If I send you over, that means it's time for you to collect input from a user and send it to me. So the game is when we're waiting for user input, we are literally waiting. It's not a real-time game with respect to user input. P-value is how I will tell you and how you will tell me, actually. So I'll update the documentation. I'll tell you that player number one should be rendered with a certain value for power and angle. Player P-num will be 1 or 2. There'll be more to come. All right, you're free to use C or C++. I would choose C++ because I, for example, make extensive use of stream strings for formatting and parsing of the commands going back and forth, and other features of C++. You can have a partner, and both of you must turn in something. One of you will turn in the source code of your game only, not the controller, your game only. So I don't want to see a zip file. I prefer not to have to unzip your files. And the partner will send a text file. If it's not a text file, if it's HTML, if it's an XML, if it's a PDF, well, you just get a 0. I'm done with that. Speaking of things I'm done with, the deadline is the deadline. There's no late work on this one. So let me show you what this might look like. Close that and a new share the terminal. Okay. All right, so what I've got here, notice I've got a lot of characters. If you look at my title bar, it says that I'm 164 columns by 52 lines. So that is more than enough to play the game. First, I will show you what happens when you don't have sufficient resolution. So this is too small. LS, notice there is the README. Ignore this file because it's just log output that I generate in my controller. It won't be enabled when you get the source code. You'll see how. Shell script rather than a make file. It was just easier to build. So this is what this is the executable you're going to make, called game. And here is my executable called pipe tank controller. You will be getting this source code. So /game. Notice that there's an error message. The error message text is created by you. However, the controller, you told the controller 41 by 18. And the controller told you resolution, and it failed to start up. Okay, so now let's look at it, what I have so far. And here's the tanks game that I have so far. Here is the ground, way down here is the ground. Here's player one, here's player two. The initial angle and power readings are set here. This is where you'll position the cursor and get the user input for player one. You'll alternate between player one and player two and getting the user input for player two. There is no computer controlled player because, once again, you're rendering. I'm doing the calculating. So if there was a computer controlled player, it would be on my side, and I'm not doing that. So this game is not operational yet. You can see the box around the screen. You can see the terrain. You can see the position of the players. There would be, can you see my cursor? Just somebody out loud, because I'm not looking at you.
Yeah,
I can see it.
Okay, so player one would fire at 45 degrees, the way this is set up right now. And what I'm looking at is over here. Player one would fire a shell at 45 degrees, and I will tell you how to draw and erase. The shell will have a ballistic path, land here and blow away some ground. Then you get the input from player two, you send it to me, and then I calculate that player two is going to go off the side of the screen, and so on. Okay, so that's the game. Anybody have any questions so far?
When do you think you'll be done with this game?
So it's signed by Friday, or is it Monday? Did I sign it ready for based on Monday? Is it due on a Monday or a Friday? Take a look.
I
It's
believe
Monday.
What?
It says on the Schoology, it says Monday, May 2nd.
Okay, so the spec will be finished by no later than Monday. Now to give you expectations, so I'm writing the documentation. I'm writing both sides. So I'm doing approximately 3 times the work that you'll be doing. And I figure all told, it'll take me about 6 hours. All right. So let's say, let's just take a guess. Your time, you're doing 1/3 the work that I'm doing. Let's say you take, I don't know, 12 hours. So I think this is a 12-hour project spread over 2 weeks and spread over 2 people. But of course, it's up to you to make sure your partner pulls their weight. Okay, next question about the project. Okay, nobody? Okay. Yeah.
I got one more question. I didn't really see like what you would be grading. So like what would you be grading on this project? Just like the functionality of the game and seeing if we were using your stuff correctly.
Yeah. What does it work? Does it work correctly? Then look at your code and see if I can make sense of it.
Okay.
Okay. So let's see, there's one more thing I can show you, and that would be, since my program is also standalone, here's the output of, so here's the output of what I would be sending you. Pipe, and let's say 52. Let's see, it's columns first. So 164 by 52. And I'm going to pipe that to more. Okay. So here's the startup. I'm telling you to, at position 1, 1 on your screen, draw an underscore. Notice you didn't see any underscores. So underscores are to be replaced by you with spaces. The reason I did it this way is so that you could see when there's a space. Because if it was just a space, you wouldn't see it and you'd have no idea what I was trying to draw. So wherever you get a draw command with an underscore, you render a space. Okay, now this is going to go on for a long, long time because most of the board is the sky. Okay, all of this is being sent to you from my program to your program via a pipe, and you are continuously reading from the pipe and are figuring out what to do. Now, let me do this again and do the very end. Okay, come on. Let's look at the end of the data. Can't take that long. All right, let's do it like this then. All right, and now tail output. Okay, so here I'm telling you to draw some ground. All right, I'm telling you to refresh the screen. I'm telling you to draw the two players. Telling you to refresh the screen. That's a little bit gratuitous. And then I'm telling you what values to render for player 1 and player 2. And then I say over. So that means that the controller is done sending you data. Don't look for more data from the controller because you're using blocking reads. If you try to read when I haven't sent you anything, you're just going to block. So when you see over, you know it's time for you to move on to the next step, which in this case would be to get user input for player 1. You send it to me. I send you a whole long series of other drawing commands followed by over. And then you get player 2's info, send it to me. I send you a whole bunch of drawing commands, etc. And the process repeats until somebody dies. Okay, anybody have any questions? RJ, I noticed that you just arrived. I am just about finished describing the next project. I'm sorry you were not here for that. Okay, so you'll have to consult the specification.
All right, yeah, sounds good.
Okay. All right, so nobody has any other questions? Okay, very good. So let's see where we were last time. Come on. All right, give me a second and okay, so what we went over last time. Come here, pencil. And good. So what we went over last time is fork and exec, and this is a family. The exec that I happen to be using in my version of your code happens to be exec L. So let's go over these again just to review. So fork is how new processes are created, not new threads. It's called fork because one process calls fork and two processes return. Okay, everything about the two processes are identical with the exception of the return value of fork. So you'll say PID equals fork, for example. And if the PID is 0, you're the child. Otherwise, you're the parent. You're the parent, and the PID is the process ID of the child. Anyone have any questions? Okay. Reminder that everything other than the return value is identical. So If you have any open files, they are open in both. If you have the contents of all the variables are identical, with the exception of the return value of fork. Any memory you've allocated is identically configured. They are the same in all respects, except for the return value of fork. Now, let's talk about how, well, let's now do exec. So exec L is but one of 4 or more versions of exec. This one is quite straightforward. Yeah, let's take a look at it. Parameter 0, parameter 1, parameter 2, etc. until 0. That's not right. Let me make a small change. Get rid of that, get rid of that, get rid of that, and put in path P0, P1, etc. Okay, so path is the path to the executable. So in the case of your project, it'll be /pipe tank controller. And P0 through Pn-1, well, that's argv. That's not argr, it's argv. Right, so what is the first value, which is always supplied as your first parameter, command line argument?
Program name.
Program name, yeah. So whatever you put here, you can also put there. Okay, so you can just repeat, whoop, silly me. You can also put here. So you can just repeat the path as P0. After that, you're going to have 2 more strings, and that's going to be first the number of columns, followed by the number of lines, and then the all-important null. So you are literally setting up argv and indirectly argc right here. Anybody have any questions? Okay, good. So let's turn our attention to pipes. Okay, here is a picture of a pipe. Okay, so as it suggests, it's unidirectional. So this is the right side. This is the read side. Both of these are returned to you in the form of file descriptors. Descriptor. File descriptors. A file descriptor is a, come on, that is a feature I have to turn off. If I do something that I'm not quite sure what it is that I do with the pencil, it flips into erase, which in theory sounds like a good idea, but in practice, not so much. Okay, so file descriptors are small integers. So what do you think, what would you guess a file descriptor really is?
Some struct that tells us some stuff about the file we're accessing.
Nope, not quite. Let's see, I noticed that, please forgive me, give me a moment. I do want to see if I've marked Eric as present. Okay, so he is now here. And let me save that. All right, the people I have missing now are Caleb. Caleb, are you here? And now I've adjusted RJ. Okay, so RJ is here. Where was I? I'm presenting the, there, okay, good. All right, so anybody else want to take a stab at what is a file descriptor? I've told you it's a small integer. Okay. Okay, very often when you're given a small integer by an operating system, for example, it's an index. It's an index into an array. So file descriptors are array indices. What is the array? The array is your per process open file table. So in kernel memory kept for your process, there is an array. See, it went into the erase again, and I don't know what's doing that. There is an array called the open file table, and it has indices 0, 1, 2, up to n-1, where n-1, I believe, is a constant, a define that might be something like max files. But don't trust me on this because that's only a dim recollection. The value for early Linux and early operating systems of the Unix variety was 20. So max files was 20. Today, I believe it's 64 on Linux, but I could be wrong. Now, I only drew 0, 1, and 2. Anybody want to tell me what 0, 1, and 2 are? Don't make me cry.
Indexes?
Yes, they are indexes. What are those array slots referring to?
Isn't 0 dragons, like the null references?
Not in this case. 0 meaning address 0, virtual address 0 is in memory would be dragons. Yes, insta death. No saving throws. Okay. Well, you've been using array indexes 0, 1, and 2 ever since day 1 of your programming careers. Does that give you a hint?
I think Daniel put the answer right in the chat.
Thank you, Daniel. You are correct. C in, C out, and C air. This is C++. Those are streams in C++, which are wrapped around standard in, standard out, and standard air. And that's what we've got here. Okay, so file descriptor 0, you can read from by default. It's standard in, it's CIN. File descriptor 1 is standard out. You can write to it, it should show up someplace. Standard error is file descriptor number 2. That is the same as CAir. Okay, by default, listen to me, by default, C out and C air both go to the same place. So by default, file descriptors 1 and 2 both go to the same place. Okay. So the lowest level of reading and writing on the system is with read and write. They both take file descriptors. Okay. So if you were to read from 0, you're accessing standard in. That's a repetition of what I just said. Comma, comma, and this would be some type of address and some count. Same thing here. These both return values. It is critically important that when you use read and write that you look at the return values. Okay. Okay, so let's get back to pipes. What does this have to do with pipes? One of the brilliant things that was incredibly ridiculed by Microsoft until they didn't, is that everything on Unix is a file. Everything. Files are files. The hardware is represented by files. Memory can be represented by files. Okay, so pipes can be represented by files. Network connections can be represented by files. And that was brilliant. It was absolutely brilliant because that uniformity means that the model that programmers have to worry about is uniform, the same no matter what. Nathan Myhrvold, one of the original programmers at Microsoft, famously ridiculed that. Well, what can I say? In this regard, this otherwise very, very smart guy was an idiot. So it is, in fact, one of the virtues of Linux and Unix that came before it. So let's take a look at pipe. In order to use a pipe, you declare an integer array. And it has exactly two members, 2 ints. Guess what those ints are going to be? A file descriptor for the read side and a file descriptor for the write side of the pipe. Okay. Now, by the way, there are 2 kinds of pipes. We're only learning about the first one. I'll describe the second one. Okay, so any return value is equal to pipe and you give the address of the array. You'll then check the return value, make sure it's kosher. And if it's kosher, you will find that the pipe system call has filled in index 0 and 1 with file descriptors. All that remains now is for you to know which is which. Okay, there's a read side, that's one of those two integers. There's a write side, it's another one of the integers. It's up to you to look it up. Okay, how are you going to look it up? You're going to go to your terminal and you're going to say man to pipe. You're going to read this. The answer's on screen right now. You're going to read this and you'll figure out what index is the write side and what index is the read side. If you confuse the two, your program will simply not work. You'll hang or worse, okay? Something else is you need to know the name of the include file where pipe is located. So it's unistd.h. You also need to pay attention to the return value. If all goes well, the return value is 0. If there is an error, the return value is less than 1, less than 0, and Erno, our friend Erno, is filled in with what went wrong. And you can use our friend Pierre to print it out, okay? Okay, now a few more things. Let's go back to this picture. As you might imagine from this picture, the pipe has a finite capacity at any one time. It has an infinite ability to transmit data, but only a certain amount at a time. When the pipe becomes full, writing to it causes your program to block. Your process will continue to be blocked until room is made in the pipe, at which time you'll be rescheduled and you can continue filling the pipe. How do you make room in a pipe? Well, you read from it. If you read from an empty pipe, you become blocked, and you will remain blocked until something is in the pipe. How do you get something in the pipe? Somebody wrote to it. Okay, so there's this inherent synchronization between the reader and the writer. If the reader is faster than the writer, the pipe will become empty and the reader will block. If the writer is faster than the reader, the pipe will become full and the writer will block. Okay, this is known as a producer-consumer pattern. This is a famous pattern. It shows up again and again and again. Another way of visualizing a pipe is a ring. The ring, of course, is not really a ring. It's an array. Think of it as a vector of character. Here's index 0. Next to it, logically, not physically, is n-1. Now, like a circle, this array has a finite size. However, since it can go round and round, it has an infinite capacity over time, just like a pipe. A pipe at any moment has a finite capacity, but over all of time, it has an infinite capacity. So this ring is called a ring buffer. That is a producer consumer. It's also another common name for it is the circular buffer for obvious reasons. That is also a producer consumer. Okay. Anybody have any questions?
So we've seen here how to set up a pipe. Maybe I'm just missing something obvious, but where here does this say let us go from one program to the other? How do we specify that this pipe is supposed to talk to a second program?
That is a great question, Joe. Thank you for that question. I've already answered it, but I didn't tell you I was answering it. So let me tell you in detail. If you recall, I said every aspect of the two processes after the fork are identical with the exception of the return value of fork. And I called out every open file is still open in both parent and child. And and I'll just finish and then you talk. I'll finish the statement. And I told you that pipes look like files.
So we open the pipe in the first program, then fork and exec. And then they'll both share the pipes.
Exactly right. Listen to what Joe said. Listen to what Joe said. He said you have to create the pipes before you fork. Common mistake. If you try to create the pipes after the fork, they exist in only one of the two processes. They're not shared. So you have to create the pipe before you fork. Okay? But the story does not end there. A pipe. So let's draw a picture. So we've got the read side, the right side, and the read side, and they're now shared. You created the pipe before you did the fork. One detail before Joey thinks of asking it as a question, because I know he would, because he's a sharp cookie. Exec preserves open files. Okay. All right. So you've created the pipe. So this is FD for writing, and this is FD for reading. And as I mentioned, that's going to be one of the indices in the array, and the other indexes in the array, the other member of the array is the read side, one array is the write side. Okay, so these are now both shared in the two programs. So here is the parent, and here's the child. Both of these have the write side and the read side. Now the pipe is unidirectional. That means it only goes in one direction, either from the parent to the child or from the child to the parent. You're the programmer, you design it, you know which is which. Okay, so the idea is that well, it's not always this case. Let me just run a quick demo and then we'll explain. Okay, so here's LS. Everybody see LS on the screen? Okay. Here's word count. What is word count doing? It's waiting for me to enter input. And now I'm going to give it Control D, which is the end of file. And then word count read everything that it got, and it said there are 4 words on 4 lines with 33 characters. So where was word count waiting to read from? Standard input. Okay, the console, cin. Now, let's take ls, pipe, bing, bing, bing. That means pipe means pipe. Pipe that to word count. Notice that word count acted immediately. It didn't wait for me to type in. Why? Because its standard input was the standard output of ls. Okay, so here's your, so I'm gonna, does anybody have any questions about what I just showed? Because I'll flip back to the iPad. Okay. So let's say this is ls, which isn't, but which it isn't. You'll figure it out in operating systems. And let's say this is WC. So initially, 0, 1, 2, 3, and 4. 0, 0, 1, 2, 3, and 4. Last time I only drew 0, 1, and 2. This time I drew 2 more. Why? Because the parent created a pipe. Right? So that's 2 more file descriptors. By the way, whenever a file is opened, whether it's a real file, whether it's a piece of hardware, whether it's networking, whether it's a pipe, whether it's a whatever it is, the first available entry in the open file table is where the file descriptor goes. So this one is currently hooked up by default as standard out, in, out, air. So where are the pipe file descriptors going to go? This is going to be the read side. This is going to be the write side. This is also the same standard in, the same standard out, the same error. This is also the same read side. This is also the same write side. In the child has not yet become WC. So the child notices it's the child. It closes 0. Zero is now available. It then calls a system call called dupe, which will duplicate a file descriptor. It copies a file descriptor from one place to another. You tell it where to copy from, and it will look at the open file table and fill it in. So I'm going to dupe, in this case, let me give myself some drawing room here. I'm going to duplicate the FD for the read side. And I got that from the array that was filled in by pipe. Okay, so now here's the read side. So that means when this child ultimately becomes word count, when it reads from standard input, it's reading from the pipe. It's not even aware. You get it? It's not even aware that it's reading from a pipe. All it knows is standard input is standard input. Okay, so this one's going to be LS on the left, so it's going to close standard output and call dupe to put the right side of the pipe where standard output was, so that when this process becomes LS and it writes to the standard output, it has no idea that it's writing to the right side of a pipe. So you don't have to alter the programming for LS, and you don't have to alter the programming for word count. Brilliant. Okay, but we're not done. There are some final steps that are absolutely necessary in order for your programs to work correctly. And that is, you must go back and do the appropriate bookkeeping, whether you're the parent or the child, to clean up, to make sure that anything that is redundant or unnecessary is closed. So for example, LS is only writing to the pipe. Therefore, it must close the read side. Second, LS, or the parent, which will become LS, has now duplicated the right side. It must close the one that was left over. Okay, now look at the left-hand side. All the redundant or unused file descriptors are cleaned up. Now let's look at the child on the right. It will not be doing any writing to the pipe. That's the job of the parent in this case. So it must close the right side. The read side has already been duplicated into standard input. In order for this program to work correctly, that must also be closed. Now, look at the read side, look at the right side. They are both cleaned up. You are not simply being a good camper here. These are necessary steps for your program to work correctly. Anybody have an idea why? How would you, what's one way that a child might know the parent exited and that it reached, well, LS runs, right? The word count, LS is the parent, word count has to know when the input from LS is done in order for it to give you a proper word count. How does it know? It's reading from standard input. Think about it, reading is from CN. How do you know when you reach the end of your input?
When good is false, I think. It's like cn.good is false.
Yes,
So
that is a technically accurate answer for C++. But what does that mean?
You've reached the end of the file, or
Perfect. Stop there. Don't say anything else. Okay, good. Perfect answer. When the read side of WC, right? Read side of the pipe, it's the standard input to WC. When it gets an end of file from the reading, trying to read the pipe, it knows that there's no more input and it's done. Now, how does the end of file get signified when you're working with a pipe? The right side closes. So look now. Look here. If the right side was still here and it was open and you closed this one, it's still open. So end of file doesn't happen. Okay. So it is critical. This bookkeeping that I just showed you and described is actually necessary for the correct working of a pipe. We have a minute left. Who's got questions?
So since you duplicated the right side and read side, would you not need to close the duplicate ones, or are they different enough in some way that they don't?
I did.
Oh, you did?
Right.
And that went right over my head.
Yeah, see, there's nothing here and here and here and here.
But you duped the right side over to where standard in would be, or standard out on LS's side, my bad, and read into 0. Do you not need to close those again? Since the right side.
What, these?
Still, yeah.
Well, just like all open files, when the program exits, it will, those open file descriptors are closed.
Okay. So we're just
Right.
letting those ones get closed by when our program exits. Okay.
Right. Okay. Another question. Then I'll give you one last piece of new knowledge and only take a second. So I said a file descriptor is a small integer. That is a very, very common pattern, which is called an opaque value. It's a value which is important, but it gives you no information. So for instance, given the small integer, what is the struct that is inside the open file table? I don't know. I got no information. So you're hiding all the details of the implementation by just handing out the index to the array. All right, today is Wednesday. There's no class on Friday and no class on Monday. And if you have any questions, we talked about at the beginning of class, you can reach out to Noah. Noah, you know I'm kidding, right?
Not funny.
Okay. All right, let's have a vote. Who says that was funny? And just keep in mind your grade depends on it. There you go. Okay, everybody.
You'll take enough from me, right?
Have a great holiday, and I'll see you on Wednesday at a week from now.
You as well. Take care.
Thank you. We'll see you next week.
I have a little
Adios,
bit of
Professor.
Thank you.
I have a little bit of an issue that is not related to this project, but I started working on. I actually started figuring out what I was supposed to be doing on Project 5 on Wednesday. No,